everyone, I'm Dr. Jagadha, Professor and Head of the Department Mathematics, Institute of Aeronautical Engineering. The subject we have selected for this video lecture, Probability and Statistics, in which rank correlation is our topic. So in this video lecture, what all we are going to discuss about? First, we are going to discuss about definition of rank correlation. So rank, the word, school, the study on words, we heard about the word rank. Whatever the exam, if you write, what is the rank we got it regarding our academics? So regarding this rank, how it is correlated between our relations. They are represented as variables. All the mixing this concept we are going to discuss. Rank correlation, how it is defined, and problems based on rank correlation. Then the psychologist and also the mathematician, the spearman, he defined the rank correlation. Based on that, we are going to do the problems. The first one is the rank correlation. The introduction about is a British psychologist, Charles Edward Spearman. He found that the method of finding the coefficient of correlation by ranks. So he was the first person introduced the rank of correlation. We know it what is correlation, that is a relationship between the variables. This method, which is based on rank and is useful in dealing with qualitative characteristics such as morality, character, intelligence, and beauty. It cannot be measured quantitatively as in the case of Pearson's coefficient of correlation, because called Pearson's coefficient of correlation, it is based on quantitative, whereas Spearman correlation is based on quality. The rank correlation. The formula which is defined by the Spearman, so naming, bearing his name, the formula which is named as Spearman's rank correlation, which is given by rho, which is equal to 1 minus 6 summation d square divided by n of n square minus 1, where rho, which is represented as rank coefficient of correlation, d square, which is represented as sum of sum of squares of the differences of two ranks. You can see between the ranks, the difference, the subtracted value, we will do the square, and everything, the summation, it's nothing but the d square. Here in the formula, the symbol which denotes summation. What about this capital N? It represents number of paired datas. So that's what which is written here, number of paired observations. Now the properties of rank correlation coefficient. That is the first one. Just now we have discussed the value of how to find the value of rank correlation using the Spearman's formula. So if you get some value, the resultant, compulsory it should lie between +1 and -1. So the two possibilities, either +1 or -1. So now suppose in case, if the value is 1, then it is a complete agreement in the order if the ranks and the direction of the rank is same. This is the previous or one more video. It is uploaded in the YouTube channel. That is correlation. In that video, it is clearly explained about the directions. So everyone, the students community can utilize the watching those video. The direction it's mentioning, it is clearly explained in that video. The next one is rho, which is equal to -1. Then it is completely disagreement in the order of the ranks, and they are in opposite direction. So if the value which is equal to +1, agreement. If it is -1, it is disagreement. This point also we have to remember. So the problem we are going to do now using this rank. The following are the rank obtained by 10 students. We have to read the question carefully. The question itself, it is given 10 students rank. Following are the rank obtained by 10 students. 10 students ranks are given. In 2 subjects, they are statistics and mathematics. Fine. To what extent the knowledge of the students in 2 subjects, they are related? That we have to find. So the data, we can see it. So the first subject is statistics. The data are 1 to 10, which is given. The second subject is mathematics. And the data are 2, 4, 1, 5, 3, 9, 7, 10, 6, and 8. So the 10 data regarding the subject statistics and mathematics, which are displayed here. We have to find the rank correlation. The thing, we have usually the students when they're writing the exam, we have to spend the time while reading the question which is given to find correlation or rank correlation. Our problem is rank correlation. So that's what we selected, Spearman's rank correlation. It's only correlation, then we will go to call Pearson's coefficient. This point, we have to be very careful and we have to pay attention while reading the question, more attention to be paid. So the formula for Spearman's rank correlation is given by rho, which is equal to 1 minus 6 summation d square divided by n of n square minus 1, where rho is a rank coefficient of correlation and d square, it's nothing but sum of squares of the differences of 2 ranks. And capital N is nothing but number of paired observations. So now we are going to construct the table. On what basis we have to construct the table? That is our first point. The base to construct this table is what are the term values which are needed, which are required to substitute in the formula. On that basis, we are going to construct. So now, computation of rank correlation. This is actually here it should be placed because of the lesser space it is kept the side which is written here, computation of rank correlation. The first one, rank in statistics. Because in the question itself, rank of the 10 students which are given. So rank in statistics, that we named it as the variable X. The subject is probability statistics. Our topic is rank correlation. Correlation, whatever the relation. Here our relation is rank in statistics. That we have to take, we have to assume. Our assumption, assumed or converted into a variable, that is X. Under which, what are the data are given? for rank in statistics which are listed here. All the 10 data we listed. 1, 2, 3, 4, 5, 6 up to 10. Now, the next one is rank in mathematics. That is Y. Here you can see it. Here the data 2, 4, 1, 5, 3, 9, 7, 10, 6 and 8. All the data for Y which is written here. We need the formula. There is a term summation d square is there. To get to the d square, first we have to find what is d. The d is nothing but difference between ranks. So x minus y, that's what it is written, because we know very well what is x is nothing but rank in statistics. Our y is nothing but rank in mathematics. So we can see it. So 1 minus 2 minus 1, 2 minus 4 minus 2, 3 minus 1, 2, 4 minus 1 minus 1, 5 minus 3, 2, here 6 minus 9 minus 3, 7 minus 7, 0, 8 minus 10 minus 2, 9 minus 6, 3, 10 minus 8, 2. It's d square. It is 1, 1, here 4, 1, 4, 3 square, minus 3 the whole square. That is, we know it, the negative the whole square is always positive. So 0 square minus 2 the whole square, 4, 3 square and 2 square. So all the complete this data is d square we have obtained. We needed summation d square equal to 40. So we obtained the final result of the summation of d square is 40. So now the formula for Spearman's rank correlation is rho, which is nothing but 1 minus 6 summation d square divided by n of n square minus 1, where rho, rank coefficient of correlation, d square, sum of squares of the differences of two ranks, capital N, number of paired observations. So what we obtained, the result which is kept here, summation d square equal to 40. Here we substituted rho equal to 1 minus 6. This is the result we obtained, 40. Divided by n. The capital N, it's nothing but 10. That is number of paired datas we obtained, the total is 10. Here 10 square, it's 100 minus 1. So the simplification part, the 1 which is written, the minus we kept as it is. This simplification we obtained 240. Here the simplification is 990. So 1 minus 0.24, that is 240 divided by 990. The final result we obtained 0.76. So we completed the problem. We obtained the result 0.76. The property of the rank correlation, it lies between minus 1 and 1. Yes, it satisfied the property also. What is the result we obtained? So now we can see it here. So this is the data, depends upon the data. So this is the question, actually we got it, rank in statistics. We prepared and we constructed the table. D we obtained it, d square and summation d square. This we substituted in this particular place. Yeah, we can see it very clearly. Summation d square equal to 40. That only we substituted in this particular place 40. So we completed perfectly one problem. Next problem we will move. In this problem, rank of 16 students in mathematics and statistics are follows. So before the problem, just actually here the presentation of the equation, which is different here. It is given in coordinates. That is the first one, because the question, if we are noticing that mathematics is playing the role first. So the first one, this data is represents for max. This is statistics. Next 2, 10. 2 plays a role for mathematics. 10, the value is for statistics. Similarly, 16 students data are given. What they are asking, calculate the rank correlation coefficient for the proficiencies in this group in mathematics and statistics. So we know it, the Spearman's rank correlation formula is rho equal to 1 minus 6 summation d square divided by n of n square minus 1. So here we can, this is the formula. The formula for Spearman's rank correlation is given by rho equal to 1 minus 6 summation d square divided by n of n square minus 1, where rho, which plays the role of rank coefficient of correlation, d square. We have to find the difference of two ranks, and we have to do the square, and we have to do the summation. That is, this is the symbol for summation. And capital N is playing the role of paired data. In our problem, 16 paired data, students' data for the subjects mathematics and statistics. So here we can see it, the data. So we are constructing the table. The table, actually the heading to be kept here because the slide adjustment purpose, it is kept here. Rank in mathematics, that we represented as the variable x. All the data, 16. Next, rank in statistics, we represented as that rank in statistics as the variable y, and d, which is nothing but x minus y. Here we can see it here, 1 minus 1, 0, 2 minus 10, minus 8, 3 minus 3, 0, 4 minus 4, 0, 5 minus 5, 0, next 6 minus 7, minus 1, 7 minus 2, 5, 8 minus 6, 2, and 9 minus 8, 1. Here 10 minus 11, minus 1. Just we are doing the subtraction. 11 minus 15, minus 4. 12 minus 9, 3. 13 minus 14, minus 1. 14 minus 12, 2. 15 minus 16, minus 1. 16 minus 13, 3. The next one is d, we found it. Now d square, the complete one, we have to do the squaring. So here square, here 64, 0, 0, 0, 1, 25, 4, 1, 1, 16, 9, 1, 4, 1, 9. So completely d square we found. Sum of the squares of the difference of two ranks, that is our d square, which is defined for it. So we have to do the complete this data. We have to do the summation. Addition, we have to do it. So we have done it. Summation d square equal to 136. So now, the formula we know it, rho which is equal to 1 minus 6 of summation d square divided by n of n square minus 1. Rho is nothing but rank coefficient of correlation, d square sum of squares of difference of two ranks, n number of paired observations, paired datas which are given in the question. So once again we have written the formula. The particular place, this place, summation d square, that is this is the data we found. We can see it. It's clear. This data we substituted in the particular place. Yeah, it's very clear now. So 1 minus 6 into 136 divided by 16 of 256 minus 1. So rho equal to 1 minus, this simplification is 6 into 136, that is 860, divided by 4080. So rho, finally we got it. This simplification, 816 divided by 4080, we got it 0.2. So the result is 0.8. So using the table, what we constructed, this is the table we constructed, this value we obtained, that we substituted in this particular place. So we finished the sum. The final result is 0.8. So we completed the second problem also successfully. We will move to the next problem. So this is a formula, just it is kept here. So we will move to the next problem. A random sample of 5 college students is selected and their grades in mathematics and statistics are found to be, here we can see it, 5 students, mathematics, their marks are given 85, 60, 73, 40 and 90. And statistics, what they obtained it, 93, 75, 65, 50 and 80. That is the first student, what he scored in mathematics is 85 and statistics is 93. The second student in mathematics 60 he scored and 75. This problem, and previously we discussed just now so far 2 problems. What is the difference between those 2 problems and this problem? Those 2 problems, the rank is given in the question itself. But whereas here the rank is not given. They are the first student, second student, third student, fourth students, fifth students. That's it. Their marks are given. Ranks are not given. Calculate Spearman's rank correlation coefficient. This is the formula which we are going to use. Very familiar now, the formula to us. 1 minus 6 into summation d square divided by n of n square minus 1. So everywhere the problem, we have to read the question carefully what is given. Related to that problem, the first presentation, what we have to write regarding that formula. So formula for Spearman's rank correlation is rho equal to 1 minus 6 summation d square divided by n of n square minus 1, where rho is playing the role of rank coefficient of correlation, d square which plays the role of sum of squares of the differences of 2 ranks, capital N equal to number of paired observations. Here you can see it very well. We are going to construct the table. So now, computation of rank correlation. So mark in mathematics, X. Here 85, 60, 73, 40 and 90. Now here, yes, this problem, the 5 students are there. What they scored, these are the marks. Rank, it is not given. We have to declare the rank. This is the problem which is different from what we solved the previous 2 problems. This to be noted. This point is very, very important. We have to pay attention towards this. Rank we are going to declare. In what way? Here you can see it. 85, it's towards the 2 is placed. 60 towards 4 is placed. That is, the student, what they scored, the biggest one, the highest value is 90. That we gave the rank for 90 is 1. The next one is 85, we ranked 2. Next 73 only, it is 3. And 60 for 40 as 5. So we named the ranks now. Next, marks in statistics. That we named it as Y. Here 93, 75, 65, 50 and 80. Rank in Y. That is, here the highest one is 93. That is 1. Next highest is 80. That is 2. The next highest is 75, that is 3. The next one is 65, 4. The last one is 5. Now we have to find capital D. Capital D, the sum of the squares of the rank of the 2 variables. That is our X and Y. Our X is marked in statistics. Y is marked in statistics. So the rank of X, here it is there. Rank of Y, here is there. So 2 minus 1, it is 1. Next 4 minus 3, 1. 3 minus 4, minus 1. 5 minus 5, 0. Next 1 minus 2, minus 1. So D square we have to find. So the D square is here 1, here 1. Minus 1 square is 1. 0 square is 0. Here minus 1 the whole square is 1. So summation D square equal to 4. So this problem, we declared the rank and found the difference between the rank, and here we did the square of the rank, and here we did sum of the squares of the difference of the rank. We obtained the result summation D square equal to 4. Yeah, we can see it now. What is the value we obtained? Summation D square equal to 4. That we are going to substitute in the rank correlation formula. There is a formula for Spearman's rank correlation, which is given by rho equal to 1 minus 6 summation D square divided by n of n square minus 1. Compulsory we have to write the symbols, what the name, the meaning of the symbols, that is rho, nothing but rank coefficient of correlation, and D square, sum of the squares of the differences of 2 ranks, and capital N is number of paired datas. This is the formula once again which is written here, and summation D square equal to 4, that is a value what we constructed from the table we obtained. So 1, here this is the playing the role of, here we can see it, the table what we constructed. Yes, this is the table constructed. Here we can see it. The value summation d square equal to 4. That we substituted in this place. So now 1, this minus as it is. The numerator part 24. The denominator part 5 into 24. So the row equal to 1 minus as it is written. This simplification, it's nothing but 0.2, which is equal to 0.8. So we completed the third problem also. It's a very different problem. In this problem, that is only the students, 5 students, what they scored, the mark which is given. We declared the rank, and in statistics what they scored, we declare the rank. We construct the table based on Spearman rank correlation formula. That we substituted in the formula. We obtained the result 0.8. Now we will move to the next problem. So far, we completed 3 problems. That is a rank correlation between 2 variables we did. That is mathematics and statistics. Mathematics we assumed as one variable, and statistics we assumed as another variable. The discussion occurred only between 2 variables. Now, if it is more than 2 variables, how to do rank correlation? That we will discuss. 10 competitors in a musical test were ranked by the 3 judges A, B and C in the following order. So here we can see it, ranks by A. That is the 10 data which are given 1, 6, 5, 10, 3, 2, 4, 9, 7 and 8. That is the 10 students actually they participated. The musical test. The judge A, for the first student, he gave the rank 1. Second student, the judge given 6th position. Third student, 5th position, got it. Fourth student, 10th position. Fifth student, 3rd position. And this student, 2nd position, like that. 10 students, they are given, declared the result by our judge. Our judge name is capital A. Similarly, 3 judges are there. Second judge, he declared the result. The first student, he gave the position 3. Second student, he gave the position 5th position. Similarly, according to the judge B, our judge is B now. The B, he declared such a way the rank for those 10 students. Third judge is our capital C. Different judges, different opinions, declaring the ranks according to the opinion. They declared the rank for the 10, the musical test which is occurred for the competition. So the C judge, he declared, here only is there, the one student, A judge, he gave 1st position, whereas B he gave 3rd position, whereas C judge he has given 6th position. So the question is given to us based on this. Now we understood on what basis the question is framed. We got it. Now what they are asking us to find, using rank correlation method, discuss which pair of judge has the nearest approach to common likings in music. Which pair? Now A, B, or BC or CA? Who is having more liking in the music? That is our question. 3 variables are there. A is there, B is there, C is there. More than 2 variables. How to find a rank? We are going to discuss now. Solution? Yes, as usual. Question we have read. The question which is given to find rank correlation. So to find the rank correlation, Spearman, he defined the formula. First we have to write the formula. That is the answer. That is the way of presentation of producing the answer in the examination. The formula for Spearman's rank correlation, which is given by rho equal to 1 minus 6 into summation d square divided by n of n square minus 1. Rho equal to rank coefficient of correlation, d square equal to sum of squares of the differences of 2 ranks, and capital N equal to number of paired observations. Here we can see it. We will construct the table. It's a very lengthy table. Rank by A. What is the data which is given? That first actually rank by A, we assumed the variable, yes, XX. All what is the data which is presented in the question? We produced it here. Rank by B, that is, we named it as Y. All the data, the 10 data which are presented here. Rank by C, that we named it as Z. Here completely the data which is given. First we are finding D1. Previous problems only D, because only those 3 questions relationship between only 2 variables. So here we have taken only D. But here 3 variables are given. First we are going to find relationship between X and Y. Next Y, Z. Next Z, X. This X and Y, the difference, we are going to name as D1. So the D1, here we can see it, 1 minus 3, which is nothing but minus 2. Next, 6 minus 5, it is 1. Next to 5 minus 8, it's nothing but minus 3. 10 minus 4, it's nothing but 6. 3 minus 7, it's nothing but minus 4. 2 minus 10, it's nothing but minus 8. 4 minus 2, it's nothing but 2. And 9 minus 1, it's nothing but 8. 7 minus 6, it's nothing but 1. 8 minus 9, it's nothing but minus 1. So the D1 we listed, we have written. Next our target is D1 square. So you can see it, minus 2 square, 1 square, minus 3 square, 6 square, minus 4 square, next minus 8 square, 2 square, 8 square, 1 square, minus 1 the whole square. The next summation D1 square. Completely we have to do the summation that we obtained 200. The topic of this constructed the table heading is computation of rank correlation. That actually to be placed here to space adjustment purpose, it is kept aside. So the first, before constructed the previous slide, D1 we found. That is D1, the difference of the first rank, X and Y difference. Based on that we constructed. So now the leftover is Here we can see it. D2. Actually, this table also, before that table continuation, to space adjustment purpose, it is kept in the next slide. So now we can see it. Y and Z. We can see it here. Yes. This difference we did, D1. Now we are going to do difference between Y and Z. That is 3 minus 6, 5 minus 4, 8 minus 9, 4 minus 8, 7 minus 1, 10 minus 2, 2 minus 3, 1 minus 10, 6 minus 5, 9 minus 7. That difference we are going to name it as D2. Yeah, that only here. Just now what I have told the data here which is placed. Next, D2 square we have to find. Here we can see it. Minus 3 square, 1 square, minus 1 the whole square, minus 4 square, 6 square, 8 square, minus 1 the whole square, minus 9 square, 1 square, 2 square. Summation. Here actually to be found here. Summation D2 square, we will see it. D3. D3, it's nothing but Z minus X. The similar way we did here we can see it. This difference, we got it. D1, we named it. This difference, Y and Z, we named it as D2 and we did the square also. Now we are going to do the difference between Z and X. That is 6 minus 1, 4 minus 6, 9 minus 5 and 8 minus 10. Similarly, 7 minus 8. That difference we are going to name it as D3. They are listed here. So D3 square we are finding. 5 square minus 2 square, 4 square, minus 2 the whole square, again minus 2 the whole square, 0 square, minus 1 square, 1 square, minus 2 the whole square, minus 1 square. Here, the summation we have done it because it is needed. D square, D1 square, D2 square, D3 square, 3 because X, Y, Z, 3 variables are playing the role in this problem. The first two difference D1, the next this difference is D2, the final this difference is D3. So D3 summation D3 square is 60. Yes, what are the values we obtained? First, actually, we are finding row 1. That is the difference, the rank difference between X and Y. The formula is 1 minus 6 summation D1 square divided by n of n square minus 1. This is the value we obtained, summation D1 square. If you want, we can check it once again. Yes, we can see it, summation D1 square we obtained 200. Here we can see it very clearly. Summation D2 square we obtained 214. Summation D3 square we obtained 60. Yes, we came back to the current slide. So here we can see it. So row 1 of X comma Y equal to 1 minus 6 into the summation D1 square, that is 200 divided by n of 100 minus 1. The simplification of this numerator part 1200, this denominator part is 990, equal to 1 minus the fraction, the lowest form is 40 divided by 33 equal to minus 7 by 33. So the first result, the rank coefficient of rank correlation is minus 7 by 33. Now similarly, we have to do Y and Z. The difference between the first this part and here, where the difference is coming, here X and Y, here Y and Z. When we are finding the rank correlation for X and Y, summation D1 square value is substituted. Here Y and Z, summation D2 square value which is substituted there. So summation D2 square equal to 214. So in this particular place, we are going to substitute 214. So now it is substituted. Here we can observe it. So 1 minus this numerator we kept as it is. Here the denominator part is simplification is 990. So the lowest form of the fraction that is simplified one is 214 divided by 165. So the final answer is minus 49 by 165. So this all based on the constructed the table. The first one we constructed. This is the table. Actually here the extension should be there. The space, the PPT presentation purpose, space is not that much available. So we extended in the second slide. But the students, I'm requesting, you have to continue this table constructing. Continuation should be here. The next one is, here we can see it, the continuation of the table here, D2. So summation D2 square we found. Next D3, that is Z minus X, that is a judge, C judge. He given the rank for the students, that is a rank C by the judge, Z, and this is the judge, A judge. So Z minus X, D3 square we found, summation we did, and we will go back to our question. So this is the place, the current slide we have come. The last one, summation 3, Z, comma, X. So that is the C judge and the A judge equal to 1 minus 6 summation D3 square divided by N of N square minus 1. So summation D3 square equal to 60. 1 minus 6 into 60 divided by 990. 1 minus 6 into 60 what? 360 divided by 990. 1 minus the simplification is 4 by 11 equal to 7 by 11. The previous two we obtained the negative values. Here only one, that is X and Y we found, we got negative result. Y and Z we obtained also negative result. Whereas here we obtained the positive result, which is only more. Positive is more than negative. It's a simple logic. We know it. So now row 3 of Z, X is maximum. We conclude that the pair of judges A and C has the nearest approaches to the common likings in music. So we discussed the 3 variables. If it comes, how to deal. We discussed in detail this video lecture, complete knowledge of rank correlation. If it is 2 variables, yes, we are ready to deal. If it is 3 variables, fine, we will handle it in such a way this video lecture which is prepared. Now we will come to a conclusion of this video lecture. That is, first we discussed the introduction part, that is rank correlation. Correlation, it is a relationship between the variables. Rank, this method based, first introduced by Spearman, and he defined the formula 1 minus 6 summation d square divided by n of n square minus 1, and this capital D is nothing but the difference of two ranks. Summation is nothing but sum of the squares of the difference of the rank, and capital N is playing the role of paired observations. Problems based on rank correlation we did. The first two problems, in the question itself, the rank are declared, whereas the third problem, it is not declared, we declared the rank. Different problem, we handled it. And the fourth problem is quite interesting one, we discussed it. First three between two variables, whereas the last one is among the three variables, how to deal the rank correlation we discussed. So completely we finished it, the rank correlation. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.